In the 50th year after his death, Roberto Girard is finally receiving his due. In the last decade, no fewer than 7 books have been published and several international conferences have been dedicated to the composer, including this one. While Girard may be known primarily, at least in the US, as a student of Schoenberg, he also studied with Enrique Granados and Felipe Pedret, composing works that cover the gamut of French Impressionism through incidental music for film and stage and onto serial chamber and symphonic works, before also becoming a pioneer of electronic music in England. Girard's unique position as a student in Schoenberg's inner circle is reason enough to examine his writings and on the 12-tone method and serialism, but Girard also held close associations with the European avant-garde through his active involvement in the International Society for Contemporary Music. Furthermore, he developed connections with the American musical community in the 1960s, earning commissions from prominent ensembles and teaching appointments at the University of Michigan and Tanglewood. Drawing on the numerous compositions, essays, lectures, and notes he wrote throughout his lifetime, this paper will examine Girard's approach to serial composition in the last 2 decades of his life. In particular, I will examine his explorations in the serialization of rhythm and meter and his theories on formal proportions. I will show the numerous ways that Girard serialized time and space, demonstrating that many of these methods and approaches are in fact unique and differed from those of his teacher and contemporaries. Girard began exploring the temporal aspects of music composition in the 1950s. In a 1956 essay titled Developments in 12-Tone Technique, he claimed that this technique had produced remarkable achievement as seen in the works of Schoenberg and Weber, but in his opinion, it still needed further development. Girard argued that though Schoenberg didn't apply his 12-tone technique to rhythm and meter, Girard believed that the method was fully capable of doing so, claiming that, quote, both pitch values and duration values are based on numbers since they are measurable, end quote, and that number is the common basis for pitch and time. He asserted that the time series of numbers could in fact be a source of rhythmic and metrical configurations and rule articulations at all levels of formal organization. Girard explored this topic further in a series of lectures he presented while a composer in residence at the University of Michigan in the spring of 1960. Concerned with the effect of the serial function on time, he was interested in how music, to use his word, eventuates. According to Girard, when composers try to implement one series to govern both the pitch and time dimensions, this causes 2 problems. One, being that the tone row is a tonal construct and cannot also be a temporal determinant, and 2, being that if one tries to derive a time series from a tone row in hopes of coordinating the 2, then one would have to implement an all-interval series, which of course is greatly limiting, as few rows have this property. On the other hand, many composers instead adopt a companion series, generating 1 row for pitch and 1 series for time. For Girard, the idea of a companion series does not contradict Schoenberg's fundamental tenet that the series controls the pitch dimension and no other. Because the companion series is constructed solely for the temporal dimension, Schoenberg's principle can still be upheld. Girard specified that composers who use a time series should base it on a duodecimal system of durations whose durations must remain constant. As a result, a composer could decide whether to coordinate the pitch and time series, since the time series could be ordered in any way, independent of or dependent on the pitch series. This example that Girard showed to illustrate this comes from his Symphony No. 2, as seen here. In this example, one can see that the notated pitches on the staff combine to create the 12-tone series 11, 7, 0, 6, 4, 5, and so on. And above these notes are the numbers 1 through 11, and below the staff are the series of numbers 7, 3, 8, 2, 12, 1, and we keep going. While the derivation of numbers appearing above this staff should be clear, the numbers below require some explanation. After dividing the row into 2 hexachords, he reorders the opening 6-note subset into its smallest packing of 4, 5, 6, 7, 11, 0. And in the process, he essentially describes what may well be one of the first explanations of finding a set's normal order. Girard selects the first or lowest PC of this reordered subset, in this case pitch class 4, and then subtracts it from each note of the tone row to generate an independent time series as seen in the figure at the bottom of your slide. Whether he derived his series from an all-interval tone row or from a companion series, Girard generated a time series essentially to create an alternative set of numbers. He then showed how his time series could be parsed into time sets to generate a proportion for ruling additional temporal elements, creating what he called a storehouse of potentiality. A time set, as expressed by Girard's theory, is a predetermined segmentation of the time series. Favoring hexachords, Girard derived proportions from the segmentation of the time series into two halves. Each half, or time set, is composed of 6 numbers, which can be added together to create a value. This value is then compared proportionally to the value of the remaining time set. As seen in the slide, the first 6 numbers appearing below the notated pitches represent one time set. This last 6 set make up the second time set. The proportion of the time sets can be found below the bracketed segments. The number 33 is derived by adding together the numbers 7, 3, 8, 2, 12, and 1. 45 is the result of the addition of the remaining 6 numbers of the second time set. These two numbers can be further reduced by their common denominator of 3 to the proportion 11 to 15. Girard explained that he found no reason to automatically begin assigning durational values to the series of numbers. Instead, he used the resulting proportions as a timing device. As Girard aptly put it, quote, "In general, what we expect from a time set are a number of temporal specifications of various orders." In Girard's Michigan lectures, he discussed how this concept of proportions could play out in a composition. Because he used his theory of temporal proportions to govern multiple parameters, he called this the ruling proportion, found at all structural levels from the ground up. It was really the key to the superordination of the span or category of temporal events. Girard used the proportion derived from his time series to govern everything from the length of a given work, its further division into larger formal sections, themes, phrases, and he could even use it to regulate how many cycles his tone rows could make. Furthermore, Girard proposed that a composer could use more than one ruling proportion to lead a composition, but he maintained that he was, quote, "doing fine with only one," end quote, though we'll see he changes his mind about this a few years later. For example, the proportion seen here governs the durations of the overall formal sections of Girard's Symphony No. 2, and that the work is 26 minutes in length, divided into 2 single sections of 11 and 15 minutes respectively. As meticulously outlined in a 1981 Tempo article, Susan Bradshaw additionally describes how multiples of the number 26, the result of adding together the proportion numbers 11 and 15, are used to determine the tempos and the overall timings. For example, multiplying 26 by 6 yields 156, and using that tempo for the quarter note or crotchet, that number times 11 and divided by 4 for a 4/4 meter yields 429 measures for the opening movement, which with each smaller formal section being further divided into this 11 to 15 proportion. This same proportion, derived from a different time series, also governs the overall form of the third movement of String Quartet No. 1. At one level, the time series dictates the number of eighth note beats or quaver beats per bar, and in another, it also controls the choice of the time series allowed and how long each should last. As seen in the slide, the movement has no time signature, but the duration in eighth notes or quavers of each bar is dictated by the time series. The series contains only 11 numbers, as there's 2 instances of 3 in bars 2 and 6, and there are no 1s or 2s. In this case, the time series, just like that of Symphony No. 2, creates the proportion 33 to 45, or its reduction of 11 to 15. Here, the entire movement is 45 measures in length. A new time series begins every 11 measures. Because pitch classes 1 and 2 are invariant at very few specific transformations, specifically P6, RI6, R6, and I6, he combines these numbers together into a single measure, likely to make the score easier to read and to fit within this 11 to 15 proportion derived from the series. In later compositions, Girard begins to present both the 12-tone row and the time series in combination at the beginning of the work, creating what he calls a combinatory code. Many of Girard's serial compositions begin with the statement of this code, which unveils the serialized features that will unfold over the course of the composition. The code consists of a tone row in conjunction with a time series, as well as any other additional elements that may be key to the composition. Because many of Girard's serial works feature free permutation of row segments within their respective boundaries, this aspect is often highlighted as part of his combinatory codes. Likewise, Girard typically uses proportions derived from the time series to govern large-scale temporal elements, and these features are also presented as part of this code. For example, examine the combinatory code for Girard's Symphony No. 2. As seen here, the tone row begins with a low B3 played by the bassoon and the accordion. The other instruments enter in succession, presenting all 12 pitches of the tone row during the opening poco sostenuto section. Girard incorporates his new temporal series in Symphony No. 2 to determine the durations of pitches in the excerpt. The integers correspond with the length of each note measured in eighth notes or quavers. The first note of the series lasts 7/8, the second 3/8, and so on. The combinatory code for Girard's String Quartet No. 2, as seen here, appears in measures 1 through 9. The tone row begins on pitch class 2 and follows the ordering that's annotated below each system with the purple arrows. Girard clearly subdivides this opening tone row into two inversionally related hexachords, and he separates each half of the row as seen by rests in measure 6. And you can see that on the second system. The time series begins on 12 and should follow the pattern 12-1-5, 2-8-7, 10-9-6, 11-4-3. But previous publications by both Keith Potter and me have mentioned that in the opening presentation of the tone row, it appeared that the time series only governed the durations of entrances or the attack points of the second hexachord's PCs. As seen here, the smallest division of the beat in measures 1 through 9 is a third of an eighth note. Using this division as the time unit, starting in measure 6 there in the second system, the C5 in the violin 2 sounds for 10 units before the cello enters on B3 for 9 units, and following entrances of each remaining PC, the pattern 10, 9, 6, 11, 4 emerges, which is all derived from the second half of the P0 time series. However, this durational unit doesn't govern the opening hexachord, and no other singular duration appears to explain the seemingly random durations found in the composition's opening bars. However, I recently came into the possession of a partial manuscript describing numerous Girard scores in analytical details which solved some of this mystery. In November of 2015, I met Welsh composer Hilary Tan, who was a friend of the Girards and was editing his third symphony for publication at the time of his death in 1970. And upon discovering that we were both Girard scholars, she invited me to her home to examine a steamer trunk full of Girard materials, which she had initially brought with her from Wales to the US when she was a graduate student at Princeton University. We back up. In addition to the untitled manuscript with no byline, the trunk contained numerous Girard scores, notebooks full of handwritten analyses of compositions by Second Viennese School composers, Girard among them, newspaper clippings, published journal articles, concert programs, and 22 magnetic reel-to-reel tapes, some of which belong to Girard and have since been digitized and donated to the archive in Cambridge, one LP, some typed and handwritten letters, as well as 2 incomplete proposals, with the headings, quote, Bradshaw/Tan/essay, and, quote, hymnody, parentheses, Tan/Bradshaw, parentheses. The manuscript is believed to be by Hilary Tan and pianist and Girard scholar Susan Bradshaw, because there are multiple mentions of it in notes found in the trunk, as well as in letters found in the Girard archive in Cambridge. In addition, much of Bradshaw's 1981 Tempo article on Symphony No. 2 appears to be taken directly from this manuscript. The incomplete manuscript is 51 typewritten pages on with numerous annotations throughout in pen on A4 paper numbered pages 1 through 48, with partial editions of 3 pages labeled as 69, 70, and 71. There are also 44 pages of musical examples, both written out by hand on manuscript paper and handwritten annotations of excerpts copied directly from published scores. The manuscript contains brief but fairly detailed analyses of numerous Girard scores, including the second quartet. The manuscript describes in detail how Girard likely arrived at some of the proportions used to govern the various durational elements of this piece. In addition to the details already outlined, it also answers a few lingering questions. The manuscript summarizes that, quote, the proportion series is presented as the 12 durations that dictate the distance between the initial sounding of each pitch of the 12-tone row in its original form. That much we know. However, it continues providing the answer to our earlier dilemma, stating, quote, however, the pulse that indicates these durations here becomes progressively quicker. It moves from eighth or quaver to 16th or semiquaver, and then a 16th or semiquaver triplet. And you can see how that plays out here in the example from the manuscript, and then re-annotated on my previous slide. The manuscript describes in detail how Gerard likely arrived at some of the proportions used to govern the various durational elements of this piece. This chart, based on an outline by Keith Potter that was published in 1973, shows the layout of the time series and the tone rows with their accompanying inversionally related pairs used throughout. And although I'll not address the mapping of the tone rows here, as seen in the rightmost column, which has been added to this chart, the manuscript describes how Gerard derived the proportions from combining the identifying numbers of the time sets with the row pairs. It then describes how these formal temporal proportions are articulated, and in the interest of time, I'll point to just two examples annotated in the manuscript's examples. As seen here, the proportions govern temporal aspects such as pitch, phrase, section durations, attack points within a series, and the overall formal considerations. Examine here the various groupings of the 7 to 6 proportion at play in example 34D, where they are used as melodic and rhythmic ostinatos as specific durations. Each bracketed segment is governed by specific pitch constraints, as well as durational lengths dictated by multiples of the number 7 or 6. For example, anything labeled 7 could have a durational value of 7, 14, 21, 28, and so on, and 6 could be 6, 12, 18, 24, and so forth. You can note also the 5 to 4 proportions at play in the manuscript's example 34E. Something worth pointing out here, to me, when I listen to these proportional variable length layered ostinati, they seem to be very directly related to the layering of sound samples that are found in electroacoustic pieces. And so could then this late application of his proportion theory be directly related to his exposure to and experimentation with electronic tape that was happening during the same time period? I don't have an answer to that, but it's just something I've been thinking about lately and would like to start exploring, or if anyone else wants to start exploring, I think that would be fascinating. But from these specific examples, plus those shown in String Quartet number 1 and also in Symphony number 2, it's easy to see how Gerard's use of proportions become deeply embedded and permeate all aspects of the score. And as summarized in the manuscript, quote, the sections are identified not only by their rhythmic conflicts as already indicated, but also by the contrast between their different speed. That is, by differences in speed of their harmonic progress, as well as that of their rhythmic pulse, end quote. The manuscript additionally addresses this idea of speed and rhythmic pulse more fully, where it describes a second set of numbers derived from the time series, which governs the number and the relative tempos of the various sections. Here, the second quartet's time series is divided into 3 discrete tetrachords, rather than as usual hexachords, which are then summed and multiplied by 7. Now, the number 7 is not necessarily arbitrary here. There are 7 clearly marked sections in both the published and the manuscript copies of the score. And the opening note of the composition, B6, is reiterated 7 times before the next tone enters, which can all serve as clues within Gerard's combinatory code. Adding together the PCs of each tetrachord and multiplying these results by 7 yields the numbers 140, 238, and 168. Which can then be reduced by their common denominator of 2 to arrive at 70, 119, and 84. Gerard uses these numbers in rotation and rounded to their closest minstrel marking to determine the tempos marked throughout the score. Now, this analysis is confirmed by Gerard's own notes found in one of his sketchbooks in the Gerard Archive in Cambridge. As seen in this sketchbook, the row of the work, here unlabeled, is divided into 3 tetrachords before being further divided into diodes and hexachords appearing in their normal order. Typically, Girard's initial forays into such new compositional explorations are quite clear for the analyst to trace from beginning to end. For example, upon first experimenting with the idea of the ruling proportion, the third movement of string quartet number 1 is only 45 measures in length. And given just a few clues, even my second year harmony students can uncover the composition's code. That work, coupled with the Capriccio for solo flute composed as the final work of the 1940s, clearly shows that Girard is moving in a new direction. However, by the time he composes the harpsichord concerto in 1955-1956, his compositional plan becomes more difficult to follow. And upon incorporating even more temporal techniques just a few years later, the non-net of 1956 and 57, and Symphony Number 2 of 1957 through 59 are also relatively straightforward. However, from about 1960 onward, and as just seen in the second string quartet, it becomes much more difficult to follow his compositional plan. His system, as many have noted, becomes deeply embedded into the compositional framework and becomes much more difficult to analysts to unravel its secrets. As a final example, examine the combinatory code for Symphony Number 3, Collages, composed in 1960. As seen on the slide, the tone row, which begins on pitch class 5 across the top, is divided into hexachords and arranged in their normal order respectively. Girard selects the first pitch classes as horizon tone and subtracts 10 from every integer to establish the time series seen here beginning on 7, which is in the middle of the slide. Like the second quartet, he divides this time series into tetrachords rather than hexachords, and adding together the integers of each 4-member time set yields the numbers 21, 19, and 38. Girard decides then to compose a work 21 minutes in length and uses the numbers 19 and 38 to create a 1-to-2 proportion to control various aspects of the composition. According to this Tan Bradshaw manuscript, the integers of each time set are then arbitrarily multiplied by 5 and then added together to create a value used to set the tempo for each section. As seen in the slide, the minstrel markings based on the first time set is 105, the second 95, and the third 90. And as you can see, he took 7, multiplied it by 5, got 35, took 6, multiplied it by 5, got 30, took 3, multiplied it by 5, got 15, took the 5, multiplied it by 5, got 25, took all those numbers, added them together, and came up with 105, and did the same thing for the next time set and the next thing for the next time set. Girard then multiplied each of these augmented values of the time set by 5 by their respective minstrel markings and then divided them by 60 to determine the number of seconds for each section. Rounded to the next whole number, the timings should all add up to 190 quarter note or crotchet beats over 47.5 seconds. So you have this 35 plus 30 plus 15 plus 25, that equals 105. So you take the 35, you multiply it by 105, and then divide it by 60 to get 61.25. Round that to 60. I don't know why 60 and not 61, but to 60. Then take the 30, multiply it by 105, divided by 60, you get 52.5, which becomes 52. Take the 15, multiply it by 105, divided by 60. You should get 26.3, but it's turned to 34. Maybe that's the closest minstrel marking. Then 25 times 105 divided by 60, you get 43.75, which rounds up to 44. All of that added together comes up to 190. I would have never found this because I would have been finding 26 and I would have never multiplied it by 5 because that's arbitrary. I haven't found a reason why 5 is what it's doing. However, things become even more complicated once one attempts to map this out on the actual published score. The opening Allegro moderato bars are now marked minstrel markings 108, not 105, and the opening section is significantly longer than this pre-compositional plan implies. As noted in the manuscript, in the sketch version of the work, which, if I may interject, I have not seen or located this sketch version because it does not appear to be referring to the manuscript copy of the score, which is archived in Cambridge, nor does it, because the manuscript and the published score are very similar. So I don't know what this is that they're talking about, but quote, in the sketch version of this work, this plan is precisely executed with the section divided into paragraphs of 15, 13, 8.5, and 11 bars, as seen at the bottom of the slide. In the printed version, however, this opening section has been expanded to 28 bars. The second is nearly identical in shape and remains at 13 bars. The third has been reduced to a single chord that overlaps the start of the 11-bar paragraph, which has now been stretched to 16, end quote. All of which makes analyzing Gerard's music a maddening but thrilling challenge. So through a close examination of Gerard's writings and compositions, we can demonstrate the full extent of Gerard's artistic ability and creative thinking as compared to his contemporaries. And while much of his early writings revealed a fondness for the folkloric traditions of his native Catalonia and showed his unwavering support of his Viennese teacher, his output of the 1950s and 60s catered to his growing fascinations with the latest developments in 12-tone composition, serialism, and temporal techniques, some of which differed from and evolved well beyond that of his teachers and many of his contemporaries. Thus, by focusing on the creative output of his final 2 decades, we discover a body of music and scholarship that, as Marion Bowen claims, is essential to the modern repertoire. Thank you.